Now I want to determine how high the ball goes. So I know that at this height it has been 1.6 seconds. That's what I calculated, but I want to know the height there. In general in physics, if we don't have to use a calculated value, we don't want to. We would much rather use a value given to us. Otherwise, we can use a calculated value, and if we made an error, we're going to carry that error all the way down. So I'm not going to use that 1.6 seconds if I don't have to. So let's look at the information I have. How high the ball goes. Well, the V final is 0. V initial is still 16.3 meters per second. My acceleration due to gravity is negative 9.81 meters per second squared. And what I really want is my displacement, how high that it went. So I go to my formula sheet and I start shopping around. Is there some sort of relationship between V final, V initial, A, and D? And I found one. And the formula that I'm going to use is V final squared is equal to V initial squared plus 2AD. Okay, I need displacement all by itself. So I'm going to subtract V initial squared from both sides and then divide by 2A. So I have the formula V final squared minus V initial squared all divided by 2 times the acceleration is equal to the displacement. Okay, let's give it a try. Let's sub in our values. Displacement equals V final squared, 0 squared, minus 16.3 meters per second all squared, all divided by 2 times my acceleration, which was negative 9.8 meters per second squared. Okay. Looks like I'm going to have meters squared over second squared, and I'm dividing that by meters per second squared. Okay, when you divide by a fraction, it's the same as multiplying by the reciprocal. So multiplying by second squared over meters. My second squared cancel out. I have meters squared divided by meters. I'm left with just meters. So my unit here is meters. Good. Displacement is in meters. I've done something correctly. Okay, I'm going to get negative 16.3 squared divided by 2 times negative 9.81. I keep forgetting that one. I'm going to put that in my calculator. When I did that, I got 13.5417. So I'm trying to put every number in so we aren't losing any decimals. It looks like I can have 3 significant digits. So my displacement is 13.5 meters.